Hello, this is Mrs. Pullen for AP Statistics, Unit 5 on sampling distributions. In this video, I'm going to go over example number 14 from the review sheet. In response to the increasing weight of airline passengers, the FAA told airlines to assume that passengers' average weight is 190 pounds, including clothing and carry-on baggage. But passengers vary, and the FAA did not specify a standard deviation. A reasonable standard deviation is 35 pounds. A commuter plane carries 30 passengers. Find the probability that the total weight of the 30 randomly selected passengers exceeds 6,000 pounds. So, where do you start? First of all, if I were to just translate the question that they're asking, they're saying T, and I'm going to use T to represent total weight, is greater than 6,000 pounds. The variable of interest is weight. Weight is a quantitative measurement. Now, we're also dealing with multiple people, not an individual person. We're dealing with a sample of 30 passengers. So typically we would think of sampling distribution of means. We haven't really done with total sums. So I gave a hint in this problem, and you're going to have a problem similar to this on your test without the hint. So I'm going to convert the total weight into a mean weight so we can use the sampling distribution of the means. Well, what is a mean? To get the mean, it's your total sum, so in this case, the total weight, divided by your sample size. So what I'm going to do is I'm going to rewrite this expression into means. So how do I do that? I'm going to divide the total weight by the sample size. In this case, the sample size is 30. When I do that, 6,000 divided by 30 is 200. These two probabilities are the same. I'm just re-expressing my question. So now I'm in my typical form. I'm saying the probability of the total weight exceeding 6,000 is the same thing as the probability that the sample mean is greater than 200 pounds. Those two are equivalent. So we're going to do our 4-step process, which you're going to need to do for the exam and for the AP exam. And the first step is to state the parameter. When you're dealing with quantitative data and means, it's mu. So mu represents the true weight of the passengers. We now have to state the conditions. So the first condition for both the sampling distribution of the means and proportions is you either have to have an SRS or a random sample, and we're told in this problem that we have a random sample. And just keep in mind that anytime during this video, you can put the video on hold and rewind to give yourself a chance to write it down in your notes. The purpose of the first condition is so you can generalize your results to the population. The second condition is the 10% condition. We're sampling without replacement, so we're breaking the independence condition. So if we don't have independence, we can't calculate the standard deviation. However, if our what the 10% condition says, that if our sample is so much smaller than the overall population, then we can assume independence. So it's reasonable to assume that there are more than, if I take the sample size of 30 and multiply it by 10, 300 passengers and that's in the um, nation in the US, because the FAA is part of the US. So that's the 10% condition, and we verified verified both those conditions. Our third condition is the normality condition. We have to show that we can use a normal model. Now, we don't know if the population of weights is normal. It wasn't stated inside the problem. However, we know that our sample size is greater than 30, so therefore we can apply the central limit theorem. And what you're going to write is, since n is greater than 30, we can apply the central limit theorem and use a normal model. So there are three conditions, and now you must make a summary line. So we're going to say, since conditions have been met, we can apply a normal model and approximate the sampling. You can't abbreviate sampling. Distribution of, and again, this is x bars, the sample mean, with a mean. Watch the notation of mu, and you can find that on the formula sheet. And they said the average weight was 190. And a standard deviation, and watch the notation. Again, you can get the formula from the formula sheet of sigma, so 30 over square root of n. So that would be 35 over n is 30. And so you're going to enter that into the calculator, and be very careful not to round too fast, because some of you do that and you end up getting an incorrect answer. And so I would carry it out to 3 to 4 places. And so hold on, I almost wrote down in this case it's 0.390, so you can write the 0.39. Okay, now once we do that, now we can actually do our calculations. So we have our normal model, and our mean is 190. And I'm just going to restate what we did before. So the probability our total weight is greater than 6,000 is the same thing that the probability that our sample mean is greater than 200. I'm just, in case someone missed it from the beginning, how did I get the x bar from t? I just divided by n, and n in this case was 30, and that's how I got the 200. And just like before, we're going to shade. Again, this is my expectation that you're going to do this. And you're going to do normal CDF. The low is 200. The high is 9E999. The mean is 190, and the standard deviation is 6.39. We annotate. Doesn't take much time to do this. And then you enter this into the calculator, and you get 0.00588. And the last step of the process is to state your conclusion. And I typically just either restate it. I did write this one slightly different. You could just restate the original. And the probability that the mean weight of 30 randomly selected passengers exceeds 200 pounds is 0.00588. If you would prefer stating, you could state the probability that the total weight of the 30 randomly selected passengers exceeds 60 pounds is 0.0588. That would be just as good. I hope this video was helpful, and I will be making 2 more videos, one of the next example, so example 15, and one of the multiple choice.